Hi, this is Mr. Mitchell, one of the physical science teachers at Coosa High School. This is one of the videos about the math that is involved in physical science. And one of the parts that you'll have to do in physical science is deal with formulas and making sure you have the correct units with those particular formulas. So you will have what are called SI units. These are the standard units for measurements that are kind of standard throughout the world. And I pulled from the internet this particular graph about standard unit for length or distance is meter, standard unit for mass is the kilogram, time is the second, and so on and so on. So whenever you have communication between countries and communication between scientists, these are kind of the standard units that people end up using. So I have here in the center, or kind of toward the right, are three formulas that we have in physical science. This one is V, velocity or speed, equals distance over time. So what I want us to do is to kind of look and see what these standard units would be for that. Velocity is going to be distance, which is length. So the standard unit would be meters, and I will write that out here. So velocity will be, distance is going to be in meters, over, let's see what time is. Time is in seconds. So it's going to be in meters per second. You can see I have abbreviated meters, M, and I have abbreviated seconds, S. So anytime you get a speed or velocity formula, answer for the formula, it's going to need to be in meters per second. Please make sure that you are using the units. If you have distance over time and just put a number, that's not really telling the whole story. You want to have the units, and it's going to be in meters per second in most cases. Now, since the SI units have been established, we have quite a few things that go very fast. We have planes, we have very fast cars, and it's just really hard to get just meters per second for those. So often kilometers per hour, or here in the United States we use miles per hour. That is a little more commonly used with the speed than you find meters per second. But one of the next videos will be in converting from one to the next, so hopefully that won't be too hard for you once you do our practice problems here. Okay, we have this next particular formula, which is for A, acceleration equals change in velocity. This little triangle means change in, over change in time. So you know what acceleration is. Acceleration is going faster and faster. You are accelerating. You might accelerate walking. You might accelerate in your car. That's what acceleration is. So let's see what velocity. Oh, we've already seen what velocity is in. Velocity is in meters per second. So yes, above the divisible line, the dividing line, you would put meters per second. So what is time in? Well, we already saw that time is going to be in seconds. Now, here we have acceleration in meters per second per second. And that's going to end up being what's called meters per second squared. Now, it's kind of hard to wrap your head around what a square second looks like. And my advice to you is to not. I say don't try to wrap your head around what meters per second square visualizes, or what it the concept of it really looks like it. What I would advise is that you learn that acceleration has the unit, meters per second squared, and you treat it as the unit. You're finding what? Acceleration? Oh, we're using meters per second squared is what we're using. You're finding what? Velocity? Oh, you're using meters per second. So that's how I think you should approach it, by going as to what the standard unit should be. So anytime you get these figures, you are looking to use the standard unit for it. Now, I kind of cheated on this next formula. F equals ma, that's force, equals mass, times acceleration. I don't know if you can see down here at the bottom, but I put the what the units are there. And you might not can see it, but mass is going to be in kilograms. That's what mass is in. You can see mass over here. So this is force equals kilograms times, and I'll just put dot here for times. That's often what is used for times. Acceleration, well, we saw what acceleration is here. Acceleration is, yes, meters per second squared. So once again, the conceptualization should not be what does kilograms times meters per second squared look like. Just know that if you have something in force, it's going to be in kilograms per times meters per second squared. Now, we actually have a unit that equals kilograms times meters per second squared, and that is newtons. So force is going to have a much simpler unit. It's going to have the unit newtons, and a newton is kilograms times meters per second squared. So just like with the others, I would know that force is going to be measured in newtons, acceleration is going to be measured in meters per second squared, and velocity is going to be measured in meters per second. So why don't we now go, I'm going to need to erase this and go to the next slide. Why don't we go to the next slide where we have some practice for this, and you can be reading the slide while I get prepared for it. We're putting data in a formula. So we've got our formulas. Here are two of the formulas we have been working with just in the last slide. And we want to practice putting data in and using the correct units. So here we have the problem. Marie ran for 12 seconds and traveled 100 meters. What is her velocity? So we are looking for distance over time. So I'm going to put the equal sign and put the actual numbers we're dealing with here. So the distance is going to be what? Is it going to be seconds or is it going to be meters? Well, it's going to be meters, of course. So the distance is going to be 100, and make sure that you put the unit. It is meters, 100 meters. So underneath that, we have below the line would be time, which will be 12 seconds. So 12 seconds is what you have. So you will simplify, and yes, you are allowed to use a basic calculator. In your calculator, you will have type in 100 divided by 12, and that is perfectly permissible. 100 divided by 12, I happen to have already done this, would be 8.3, and I rounded because it was 8.333333, so I put 8.3. Now, I have to put the units. So the units for velocity or for speed is going to be meters per second. So Marie is running 8.3 meters per second. Let's take a look at this next one. This next one will use the acceleration formula. You're used to seeing, or at least in the last slide, you saw change in velocity and change in time. Sometimes you will see it, I think this is a good time to point out, in final velocity minus initial velocity over time. Now that is saying the same thing as change in velocity, and you'll be able to see it in this particular question. Rosalind walked 2 meters per second. For the last 3 seconds of her walk, however, she sped up to reach the door before it closed. So by the time she got to the door, she was walking at 5 meters per second. So she accelerated. She went from 2 meters per second to 5 meters per second. So 5 meters per second minus 2 meters per second is what this says, and that would be 3 meters per second. So I'll do just like I did up here. I'm going to put the equal sign out beside them, and 5 minus 2 is 3. So that would be 3 what? That would be 3 meters per second over the time, or the change in time. In this case, it's pretty easy to see what the time is. She accelerated that rate in the last 3 seconds of her walk. So that would be 3, what? It would be 3 seconds. Now, you don't even have to use a calculator to know what 3 divided by 3 is. But if you need to, you can. But 3 divided by 3 is simply 1. And don't forget the units. You may remember that the units for acceleration is going to be meters per second square. So Rosalind was accelerating at the rate of 1 meter per second square as she sped up to get to the closed door. Well, we have up at the top some practice problems, and I have put it online at this tiny URL. Now, you may have already been given a sheet that had some practice problems on it. This is that sheet right here. But if you're watching this video and have not gotten that sheet, just go to tinyurl.com/Y3LV8TPS, and you can hopefully see it on the screen here well enough to be able to see what it is. So hopefully you can go to that practice problems and practice this. It'll have you do the same type thing here, and that way by the time you get to class and need to use these formulas, you will have done it before. I hope this has been a good video to help you. Thank you.